In the interval from pi over 2 to pi, we want to find theta such that the cosine of theta is equal to negative square root of 3 over 2. We're essentially working backwards here. We know what the trig function value is, and we need to find the angle that makes that statement true. Since it says we're between pi over 2 and pi, that tells us that our angle ends in quadrant number 2. So it's some angle that starts on the positive x-axis, rotates, and ends in quadrant number 2. Since it says that cosine of theta is the square root of 3 over 2, in the unit circle, our hypotenuse or our radius is 1. Cosine is always our x value. Therefore, this side of our triangle is going to be the square root of 3 over 2. And our opposite side is going to be 1/2. Because this, we know, is a 30, 60, 90 triangle. And we know that because we could have found this side using Pythagorean theorem, but we've also worked a lot with 30, 60, 90 triangles. So by now you should notice that if you have a hypotenuse of 1 and one of your sides is the square root of 3 over 2, then the other side must be 1/2. In the unit circle, or in a special right triangle, that's 30, 60, 90, the angle opposite 1/2 is always 30 degrees or pi over 6. Therefore, this reference angle is pi over 6, or you could say 30 degrees. And we want to know what angle starts on the positive x-axis, rotates, and stops pi over 6 away from pi, or 30 degrees away from 180, if you like dealing with radians better. Or excuse me, if you like dealing with degrees better. So essentially, I need to take pi and subtract pi over 6. In order to subtract fractions, I need to make a common denominator. I'm going to multiply pi by 6 over 6. And I have 6 pi over 6 minus pi over 6. And that leaves me with 5 pi over 6 radians. Or you could have taken 180 and subtracted 30, giving you 150 degrees, and then converted to radians from there.